Sorry, can you turn on the volume? Shit, sorry, I muted myself. Sorry. Oh my God.
Maybe it's a good thing.
Oh yeah, yeah. The video was very confusing. So it's okay. I'm gonna explain it again from my understanding of this shop. Okay, you're gonna create two arrays, the left and the right. Okay, the left will contain all the elements that less than 5, less than the pivot. And on the right side, we will have all the elements that greater than the pivot. Okay, so it's gonna be 3, 2 from order, 3 compared with 5, and then 2, and then 4, and then 1. Okay, on the right side we have 6, and then 9, and then 8, and then 7. Okay, done the first iteration. So we have another 5 in the middle, 5 here, which is the pivot. It's always in the correct position. It's always in the correct position. 5 is always correct position. Okay, next step, we're gonna divide this array and conquer it by dividing it again. So it's gonna, we keep this part the same. We don't touch it. Right? Don't touch them. Just keep them like this. So we then split this one into 3 smaller arrays: left, pivot, and the right. So it's gonna be this, right? Again, we select 3 as the pivot. So 3 is gonna be here, right? And 2 smaller than 3, 2 here, 1 is smaller than 3, 1 here, and here's 4. Okay, keep doing this. Next step, we're gonna have 2 at the pivot. Oh my God, it's too long now. And 1 is smaller than 2, so I'm gonna put 1 here, and there's no element on the right side, so it's gonna be an empty array. Here's gonna be 3. Here's going to be 4, and then we have the rest. So as you can see here, it's in order, right? Ignore the empty array. Oh shit. So it's in order, right? Do the same thing on the right side. So that's how it works. So let's do it. Oh my God, copy this. There, and then we tag 6 at the pivot. Oh no. Why would I choose such a stupid order? Okay, 6. There's nothing on the left, but there's a bunch of things on the right. So it's gonna be 9, 8, and 7. Okay. Again, same thing. It's gonna be 8 and 7, and then 9. Okay. And finally, we have 8 and 7. Like this. Cool. So finally, we will like it's an array, so then we can concat them together. Concat, right? Concat. We can get all the arrays, merge them all together. So this, sorry. This one should be on the right side. Okay, that's the final result. We do it from the left. We finish all the left side, and then we move on to the right side, and until we finish on the right side, it's done. So you may wonder, how the hell do we do this? How can we do this in code? So recursive. Recursive is something like you calling itself. You define a function, and you inside that function you calling that function inside, right? Calling itself. So let's do it here. I'm gonna create a function called QuickSort. Array. Okay. Oh, this one have explanation. So we're gonna pick the pivot. Let p equal the first index. What's the syntax for the first index? R0. Let's go with the simplest solution first. Okay, so next we need to define left and right. Cons left equal empty array. Cons right equal to empty array. Right? Then after you pick the pivot, you need to remove the pivot from the array itself. So I'm gonna do r.shift. Right? Shift is to remove the first element of the array out of the array. So r.shift remove the, for example, number 5 here. As you can see in our array, there's no number 5. P is a different value. So in this array, we don't have number 5, so we have to use shift to remove it. And then here we can do a for loop here. For I equal to 0, we start from 0. I less than array.length, comma I plus plus. Okay, so we can check if array I is less than P. P is the pivot here. Okay, less than P. What do we do? So here's the solution. If the current element is less than the pivot, yeah, we push to the left. Okay. Else we push it to the right. Okay. It's mostly done. You may say, what? It's mostly done. So here I'm going to return a recursive function, a recursive value. Here I'm going to return an array.concat. So we have the left part and the right part and the middle part. So I'm going to say QuickSort left, P QuickSort right. Wow, you may wonder what the hell. Right, for recursive function, we need something to stop it from running. We need a condition to stop it. In here, if the left or the right array has only one element or 0 elements, we stop the function. So here we have a condition if r.length is less or equal than maybe 1, right? We return r. Is it? Yeah. Else we do it. And here we return a recursive. This is very confusing. Yeah, this line. You can do it like this. Let results equal empty array and then results dot concat. Still work?
Wait, please fill up.
Yeah.
On line number 23, I think it did have J instead of I.
Oh shit! Why do I have J there? Sorry. Yeah, it's not defined. All right, let's try to see if it works or not before you start typing. Quick short array. Okay. Click it. Run, please work. Yeah, it does work, right? In one go. It's much easier to understand comparing to the explanation here, but that way is the most correct way because you don't generate new arrays. So here we generate a bunch of new arrays. And it's not that good, to be honest, but it's easy to understand. Okay. So you may wonder what the hell is this? So actually, for the left part, if we do the exact same thing here on the explanation here, for the left part, if we try to call QuickSort on the left part itself, so if we try to divide it again, and then we have this, and then we try to call QuickSort on the left part again, right? Just keep on doing that until we get everything in one element in an array, and then that's when we stop the recursion. So that's why we have a condition here. If you don't have this condition, you will run into an error like maximum stack call here. Maximum call stack size. So it's an endless loop. Yeah, because it keep doing the recursion even though you only will have one element.
Okay. So we don't need that if array that way.
We need it. If we don't have it, it will throw an error here.
Oh.
Endless loop. Okay. If we try to do QuickSort on just one element, an array of one element, we don't want that. We want to have some condition to stop the recursion. That's why we have this condition here. Okay, it means like if there's only one or less or no element inside an array, we stop. We return the array. Okay, that's the whole idea.
Wait, so can you explain again why it's array that way? If it's less than or equal to 1, where does the 1 come from?
1 is like, it could be 1 or could be 0, right? An empty array, there's no length, the length is 0. If there's one element inside it, it's going to be 1, the length is going to be 1. So that's why I have this condition to check. If it's an empty array, we return the empty array. If the array has one number in there, I also return the array. You can do it like this. If you find 1 is confusing, you can do 2. Same thing. But it's more confusing, yeah. So less or equal than 1 is most appropriate. So we have to check two conditions here. First is there's one element or there's no element at all. Either way, we have to return the array. Right. I hope it's clearer than the videos. Okay, I hate this one. It's a semicolon error, unnecessary semicolon. Bullshit. Okay, start running again a couple of times. Yes, they work. So, do you have any questions, Huy and Min? How do you see the chat? Oh shit, there are 4 questions. Can you turn on the volume after the video? I couldn't hear anything, sorry.
Oh, that was a while ago.
Oh, that's a while ago, sorry. Okay. Go away. So here's the whole thing, right? Really clear. Alright, the recursion here, the concept of recursion is very hard. Like, you cannot imagine what's happened inside your head at all. It's very hard. So we're going to use recursion again on the MergeSort. Do you want to 5-minute break? So you can copy the code if you want.
Yeah.
Yeah, 5-minute break. I don't think you can find the solution anywhere on the internet. It's kind of different from how people solve it. Okay. Checking up on them. Normally it take like 1 minute to answer that. It means he's not here. He's not in front of his computer. Hello Minh and Huy. Nice. Okay, maybe internet slow. There's a delay. Okay. Okay, let's move on to the MergeSort. MergeSort is actually easier to understand the concept, but I still don't know how it works in the code as well. It's very crazy. Let's close this. Close this. What's this? Python. QuickSort done. Submit. Boom, boom. Yay, done. Let's go with MergeSort. Oh shit, 11 elements, shit.
Why don't we want to filter something? We can just copy the algorithm and we still work, right?
You use .short. Yeah. .short, that's it. It sometimes runs faster than QuickSort because .short in JavaScript, it actually combine 2 or 3 different sorting algorithms.
Are we supposed to copy that array as well? Because when I load these problems from the class, and it doesn't give me an array. It says only work inside the function.
Yeah, you can create a dummy array. It's okay. Just create it. As long as you have the function called MergeSort, then it's okay. Function MergeSort, and this function has to return an array, and that's gonna be okay, right? I write code so that it will take a look at your function here. It will read your response, it return, and we will check if the array is sorted or not. So for example, if it's not sorted, look at this. I'm gonna run MergeSort. Right? And let's see if I pass it or not. You will see the same return, the same result array here. I don't console log it, sorry. Console log. Okay, run it. Same results. Nothing different. So I'm gonna submit. It's not gonna pass. Yeah, expect to see this, but it received this, which means it's not shorted at all. Why? What the hell? Why is there 68 here? Bleh, I don't know. Just ignore it. Keep trying. Yes. All right. Let's take a look at the explanation here. MergeSort. I like this. I love this short.
Today we're going to learn MergeSort. A few quick points, then we'll get to the example. MergeSort is usually done recursively. When you think of MergeSort, as with other recursive algorithms, I want you to think of divide and conquer. We're going to break our problem into smaller problems in order to solve it. Let's get started. We have the following array and we want to sort it. We're going to continuously split the array in half, our divide step, until we are left with the individual items. Watch and see.
Watch see. We keep dividing into twos.
Our array is now broken down into individual items. One note before we start sorting. When we implement this in code, these steps will be done in a different order because of recursion. But I think this human-friendly order provides more clarity in learning. Let's continue. We're ready to sort. We'll examine the individual items, compare their values, and merge them into temporary arrays. The temporary arrays are sorted, but there's work left to do. Let's jump up the recursion stack and continue. We merge our smaller arrays into a larger one, inserting items in the correct order.
So here we have to iterate through the two arrays, two small arrays. Yeah.
One more merge, and we'll have our sorted array.
Look again. It looks so easy, right?
Our array is now sorted.
But it's hard.
Here's the pseudocode for MergeSort. On the left, you have the recursive part, which has the arrays. On the right is the merge function, which combines the arrays.
Okay, how is this faster than the selection sort?
How do I say? Let's look at the charts here. Okay, we have QuickSort and MergeSort. It's not really faster. Yes, that's the worst case scenario. I don't think QuickSort is like this. I think this is wrong for QuickSort. QuickSort versus MergeSort. Space. It's more efficient and work faster than QuickSort in case of larger array size or data sets, because in its nature, it tries to divide your arrays into only one elements arrays, right? And QuickSort is kind of like it works faster in case smaller array size. So it's like this. It's a curve. It's kind of like a curve. There's some point that the two of them be like run as the same suite. For smaller arrays, QuickSort is faster, but for bigger array, very huge array, MergeSort is faster. Oh shit! Don't look at this. Right, so that's the difference between QuickSort and MergeSort. The use case, right? If you have an array of like millions elements, you may try to use MergeSort. The idea of MergeSort is some way like divide a big array into multiple one element array. Whew, let's do it. Do I record this? Yes. Let's go to code. So in the pseudocode here, you have this guy. This algorithm have two functions. This function is to split and then merge at the same time, calling merge. And merge here, just merging the arrays into one array, like two arrays into one, two arrays into one, two arrays into one. You keep doing that, right? You see you have array A and B. It means like you're merging array A and array B. You don't care about how many elements inside array A or how many elements inside array B. It's try to look through array A at the same time, look through the array B, and then we push the number into the elements into the final array, which is the results. We don't have it here, but basically we do that. And so I will try to do it. I will try to remove this part from the pseudocode, and we only focus on this. Okay, let's do it. First task, we need to divide the arrays, the big array, into two smaller arrays. Okay. It's very hard to explain it manually like this for MergeSort. It's kind of like impossible for me. You have too many different situations. Okay, let's actually do it. Okay. It's very much like QuickSort. You need a condition to stop the recursion. So you have to check if array.length, same thing, array less or equal than 1, you return array. Stop the whole array. Stop the whole function. Else, you divide the big array into two smaller arrays. So I'm going to say const left equal to something, for example, like this, const right equals something like this, right? So here we need to do something here. We need to target array, original array dot slice. We start from the left half, from 0 to where? So how do you divide one array into two smaller arrays? The middle index, right? Divide by 2. Yeah, logically it's right, but if we fail, if you don't have matplotlib. No, you don't need to. Just use matplotlib and that's it. Yeah, very simple matplotlib. If you don't have matplotlib, it will throw error if the array is length is odd, right? So you have matplotlib here. Okay. Done for the first part. The second part is gonna be array.slice. You start from this index, same index, right? To the end. That's it. Now we can try to see left and right to see if it works or not. Return left and right. I don't think you can do it. Let's see. Yeah, it's only construct the left. I would say, how do you return two elements like this? Okay, you have two arrays. The first is going to be the left part, which is this. Oh, only this, because I have 11 elements here, right? So the first is going to be 5. The second is going to be 6, 5, and 6, right? Successfully divide the array into two smaller arrays, right? Fair enough. Continue. Problem is we want to keep on dividing it, right? Keep on dividing it. So I'm gonna copy this, keep on dividing it. Let's see what happened when I run it. Yeah, you have a bunch of array inside array. So the tools here cannot show you everything inside a nested array inside array inside array. It cannot show you, so it show you like this. So basically, we successfully divide the big array into a very small one, right? Next step, we want to merge them together. All of these, we want to merge all of these guys together, so that we can have something that looks like this. Go away and like this merging. So we need a function to merge them all together on these arrays. So let's do it. I'm going to define a function called merge because I'm going to call it the merge inside the MergeSort. So I'm going to divide up above the main function. I'm gonna call merge. Merge gonna have the left and the right. So finally, it will return another array, which is the results, right? So I'm gonna call results equal an array, and then I want to return result here, right? So here we have to do some logic to merge them. You can do like this. Let I equal 0. Let j equal 0. So I want to look the two arrays at the same time. And then I will compare each element. If it's smaller, I push it to the array first, and if it's bigger, we just ignore it. I will show you in code. For example, you have an array of, you have two arrays, right? One array of 2, 4, and 5. Another array of 6, 1, 7, 1, and maybe 3. So the order is going to be like this. I want to iterate through these two arrays, and I want to find which one is smaller. Maybe 2 is smaller than 7. So I'm going to push 2 to here. Okay. And then check 4 and 7. 4 is still smaller than 7. So 4 is going to be here. Next, 5 is still smaller. 7. So 5 is going to be here. And then 7, and then 1, and then 3. Now I need to divide again. So recursive. So I need to divide this again into 2 smaller arrays and shit. Okay, this part is done. So this part, there should be no way it should be like this. It's going to be 1, and then 3, and then 7. Sorry, I was wrong. It's going to be like this, and then we check 2 with 1, 1 first, and then we take 2, compare with 3. 2 smaller than 3, so I have 2 here, and then 4 compare with 3. 4 is greater than 3, so 3 will go first. Next, 4 with 7. 4 is less than 7, so 4 will go first, and then 5 with 7. 5 lesser than 7. 5 here, and then 7. Yeah, it works like this, right? So how do we do it in code? We still while we look through all of these together, left and right, while I less than left length, and j less than right length. Okay, we open the body, we check if left I less than right j. Okay, if the element on the left side is less than the element on the right side, we push it to the result array. So result push left element. Okay. After we push, we have to increment I, so that it will ignore number 2. The next time run, it will check the number 4 here. So we need to increment I. Else result dot push, and then right side j, then j plus plus. Okay.
You spelled right wrong.
Yeah, thank you. Right. Okay. So far so good, right? So far so good. So here comes the magic. Return. Return right way. Return result dot concat. We concat the leftover of the left and the leftover of the right. Okay. There should be leftover. For example, if here, if 2, 4, 5 run out of array elements inside the array first. So there will be 7 left, right? So if there's another number, for example, 8 here. So if we run out of elements inside the left partition, the left side, we still have 7 and 8 left on the right side, okay? So that's why we need to concat the leftover as well, right? So the leftover, we can target the leftover like this, left dot slice start from I, and then right dot slice start from J. Okay, that's it for function merge.
What will concat do then?
What concat means you have an array, right? You have other arrays, and then you want to push all the elements inside those arrays into the original array. It kind of merge, yes. But concat is the method for JavaScript. Now let's see if it works or not. So here, we don't return merge, we return like this. I'm going to return merge, like so, recursive. Let's test it. What's wrong? Shit.
Right, return is on there.
Yeah, it's empty array. What's wrong with this? Let me see. Merge, we have left and right. Like 10. Oh shit, what the hell? Thank you, Smith. Okay, we have the final results, right? The magic is here. This is the magic, this is the magic. Okay. Do you have problem with this? Don't worry if you have problems. I did too. Like what the hell was it at the first? If you look at the explanation and the explanation here, this is much better than comparing to the QuickSort, right? I would say, but it's still confusing. This part here. This part here. Yeah, okay. There's this part in the explanation. They don't generate new array, but instead they try to swap this element into that element. So that's why it's harder to understand. You add and remove, basically you pop, you slide, and then add and push or concat, and then you remove using slide or shift or pop, right? So those are like not necessary. So I skip those. Instead I create a new array, left and right, and then push it into results. And that's why it's a lot easier to understand, I would say. Okay, recap. Just like the video, we divide and conquer, divide the big array into multiple one element arrays. Okay, and then we merge them all together one by one. But when we merge, we also want to do a recursive merge. So that's why we call it merge, and then we call the function itself. So every time we merge, the left array here will be in order. For example, 1, 2, 3, and the other guy will be maybe 1, 2, 5, 6, for example, but it has to be in order because of the merge up inside the merge here. Oh, how do you say? So hard to explain. All right, okay. And the most important part is the merge function. So here we have to iterate on the array left and the array right. We compare each element. If the current elements on the left less than the current elements on the right, we push that current element to results. So in this step here, I actually didn't have any logic to remove or add. I have add, but I don't have any logic to remove from the left or right array. But instead, I use the leftover here using the slice. Okay, next. Basically, the what was I? Yeah. It's okay to feel this hard, especially the recursive function. Let's console log and see what happened here, right? Let's console log results. See what happened behind the scenes. There we go. So we have 4, 3, 2. And then we have 2, 3, 4, 5 compared with 2, 5, 8, 8. Right? We have 2, 3, 4, 5, and then 2, 5, 8, 8. Where the hell is the 7? Here. So we can cut them, blah, blah. That's why I said it's very hard to do it manually. Trying to do manually like this. Just run it manually is very hard. So if you don't have any question, that's the end of the topic today. There will be one more problem. You don't have to, but you can research and try to solve that. It's called the binary search. So basically you have a bunch of names and you want to, I don't read it. If you want to search as fast as possible, you have to arrange it first. For example, if you have a question, give me the fifth, right? You have an array of numbers, right? And you got a question like, give me the fifth largest number inside an array. How do you do it? Okay, for example, this is a practical question. If you have an array of 1,000 elements, numbers, okay, and give me the fifth largest number. So that's why sorting is very important. You have to sort it first, and then you wrap the fifth element inside the array after you sort. Yeah, he's very right. Okay, that's why sorting is very important. It's got the same for name, for text as well. If you want to find someone as fast as possible, you have to sort it first, and then try using MergeSort or binary sort and wrap the name that you want. It's very hard. Okay, so that's how the database works behind the scenes. You may have a bunch of string like this, and you have to find the string with the exact value, for example, largest here. So let's try and run it again, see what happened. Let's see the speed. It takes longer than it's actually is. There you go. What? How the hell move so fast? Yeah, it's maybe coincidence. Best case scenario, maybe. You don't know.
Oh, it's faster than MergeSort too.
It happens, right? Because we have 3 different cases here. Best, average, and worst. We only care about the worst.
I have a question.
Yeah.
Sorry. Can you hear me?
Yes.
So I think it because like if you have an array that only been ascending order, then if you use QuickSort, like if you choose the pivot always is the first element, the
Oh
worst
yeah.
case will be the same as the purple sort because each time you add like the same array. You know what I mean?
I think I use a different array here.
What I mean is like I think because okay, I will.
It's kind of like use a copy of that array, like a different memory address. So we don't actually refer to the same array. We refer to different arrays. Okay. There's it's closed 7 years ago. QuickSort and Square. Is there anyone who answered this? Okay. So if you get unlucky, you chose a very bad pivot, then you run into the worst case. So deciding on how to choose the pivots is a different story.
That means actually, QuickSort is actually very bad because they depend on the luck.
Yeah. So even though the name is QuickSort, it's not very quick, to be honest. So there's some other technique to choose the pivot. The best pivot is the random one. No, not really. Yeah. Okay, so that's it. If at every time you choose the first pivot, the array is already shorted, return will add and -1 element again. Yes, almost. It's not really the random. It could be the one in the middle, maybe. Yeah. So in a lot of different example, you can choose the one in the middle. Rather than randomly choose. Insert the middle one, array like bar. Doesn't know again. 1, 2, M1, M2. What's the M? Oh. Yeah. But really, is it random is the best pivot? The chance of picking the worst pivot every time is small. There's no saying about the middle one, is it? How long until this? Oof. Is it tie? Sorting things recursive. It's originally clear. Way to choose median. Yeah, there's another way to choose it. The pivot from the median between first, last, and middle. Wow. Solution, choose wisely by random. So the solution is choose the pivot randomly. So that's the pivot is not always be the first element of the partition. Just one more line though. Randomly check the, yeah. But as you can see here, QuickSort is not that slow. I don't know how PurpleShot is so fast here. Maybe coincident. That's it. Let's stop recording.